AP Calculus AB, Unit 10, Day 3, Office Hours. So the first page was some notes, and these are some free response questions. So let's see how they're graded, where the points go. Excuse me. All right, so let R be the region of the first quadrant. Under the graph, y equals 1 over the square root of x from 4 to 9. Find the area R. So these problems are actually really good practice at everything that we've done in this chapter so far. That's going to be our next test. Finding area, which was on our last test, but it will be on this test again. Okay. So I would draw a sketch. This is no graphing calculator. So what would this graph look like? Well, this is a rational function. It has a vertical asymptote when you have division by 0, which would be x equals 0. Vertical asymptote. As you go to infinity, it goes to 0, so it has a horizontal asymptote. Really, this is a rational function. So you plug small numbers in, get big answers out. Big numbers in, you get small answers out. So it looks like this. It doesn't exist over here like other rational functions because the square root of negative is imaginary. Doesn't matter. We're only concerned with 4 to 9. So part A is just like from last chapter, find the area. So the area equals, now by the way, point breakdown here. First response questions on calculus are worth 9 points each. This is going to be 3, 3, and 3. They're not always equally split, but this time it is. I'm going to show that setup, or integrating from 4 to 9, vertical slices, y top minus y bottom. Y top in terms of x is 1 over the square root of x, 1 over the square root of x, dx. This is your setup. This is worth 1 point just for writing it down. You don't write it down, you lose a point, even if you get the right answer. So I'm personally going to rewrite it as a rational exponent, negative, and open up 1, divide by the new exponent, 4 to 9. Now your antiderivative, that's another point. Remember this part is worth 3 points. So point for the setup, point for the antiderivative, and then we're going to plug our values in. And we're going to get 2 times 3, 2 times 2, 6 minus 4 is 2. The final answer is the third point. So that's how you do it. Part B says, if line x equals k divides R into 2 regions of equal area, what is the value of k? Hey, we were doing this on the first homework of this chapter. So I'm going to say, okay, well, x equals k. We found the total area already. Half of that's 1. So we want to set up an integral. You could either do 4 to k or k to 9. 4 to k seems a little better to me. Small numbers. And we're going to set it equal to half of the area. Now, just setting that up, that's worth a point. Now, like I said, you could also instead do k to 9. That's up to you. We're going to actually do it. That's the setup. So I would rewrite it as x to the negative 1/2. And so then it'd be x to the positive 1/2 divided by the new exponent. Plug in k, 2 square root k minus 2 times the square root of 4 is 2 is 4. And it should equal 1, right? So your antiderivative, that's another point. Okay, now we're going to solve for k. So add 4 to both sides, divide both sides by 2, square both sides. No plus or minus, we're not taking the square root, we're squaring. I feel like I made a mistake. Oh, when I added the 4 over here, there's a 5 there still. So this is 5 halves squared is 25 fourths. That's your third point. All right, C. C says find the volume of a solid whose base is the region R and whose cross sections cut by planes perpendicular to the x-axis or squares. So I'm going to use my same picture up here. And so we're doing volume by cross section now. Vertical slices perpendicular to the x-axis. You got to pay attention to that. Careful. They're squares. So the volume of one slice is going to be the integral of the area in terms of x, which is they're going to be squares, which is going to be side squared. The side is the y value, but we need to get it in terms of x. Now the limits are 4 to 9, and the y value in terms of x is 1 over the square root of x squared dx. So your setup is 1 point. Now we're going to find the answer. So this is going to be 1 over x. It's going to be the natural log of the absolute value of x. The antiderivative, that's another point if you get it correct. And natural log of 9. That's natural log of 4. This would be fine for your final answer. Multiple choice, it's more likely that they would actually combine these. And that's your third and last point. So there you go. Good practice on a lot of things that we've been doing. Okay, next problem. Also, no calculator. Give you a picture this time. I'd say a lot of times they give you guys pictures on these. So no graphing calculator. Okay, let R be the region of the first quadrant enclosed by the graphs of y equals 2x. That would be this straight line, y equals 2x. Now, just because they gave me a picture doesn't mean I'm going to write all over it. And then y equals x squared, parabola. Find the area R. So find this area here. Okay, so again, good practice at what we're doing at the end of last chapter, and which will be on this chapter again, and even practice for your retest. Probably go with vertical slices. Y top minus y bottom. So to find the area, y top is the 2x and y bottom is the x squared. Should be parentheses around it, dx. The limits are 0 to 2. Now the point breakdown on this problem is also 3, 3, 3. And your setup is usually worth a point. If you don't get the setup, you lose that point. Even if you don't finish the problem, but you show the setup, you get that point. So it's good to show it. Now the antiderivative is going to be 2x squared over 2 minus x cubed over 3 from 0 to 2. That's another point. We'll plug numbers in. We get 4 minus 8 thirds minus 0 minus 0. These common denominator. It's going to be 12. Thirds minus 8 thirds is 4 thirds. So your answer is your third point for credit. So there you go. Good practice. B. The region R is the base of a solid. For this solid at each x, the cross-section perpendicular to the x-axis has an area of this. Find the volume of the solid. Now this one's weird because they usually tell you the shape that the cross-sections are, and then you have to find the area formula yourself using geometry and stuff like that. This one's a little weird. It doesn't tell you the shape, but it gives you the area formula right away. So this is actually easier. It might be a little more confusing at first, but we're going to go 0 to 2, and then we're going to plug in sine pi over 2x dx, and then we're going to, so this is 1 point for the setup, and then we need to integrate it. Now you could do u substitution, but it's just going to be an extra number that pops out. And all the u substitution is going to do is give you that extra 2 over pi in front after you do a bunch of steps. I'd like to avoid that. I would say, okay, well, I know the antiderivative is going to be cosine pi over 2x. It's got to be negative, but it's going to give me an extra pi over 2 in front that I don't want, so I need a 2 over pi to counter it. And then you get the same result as doing like 3 steps of u substitution. extra steps of u substitution. So it's up to you. You know, if you want to do that, you could do that, and you would then say it's 2 over pi sine u du, and then you'd say it's negative 2 over pi cosine u, and then you would say it's negative 2 over pi cosine of pi over 2x. I mean, that's a lot of work to get to this, like all this extra work. It's up to you. Okay, let's keep going. The antiderivative here is probably a point. Okay. Now, people might mess this up, lose that point. You can still potentially get the last point if you made a mistake here and at least do the work correctly. Negative 2 over pi cosine of pi minus negative 2 over pi cosine of 0. Now, cosine of pi is negative 1, cosine of 0 is positive 1. So we're going to get 2 over pi positive plus 2 over pi positive. It's going to give you 4 over pi. That's your third point. Okay, part C. Part C says another solid has the same base R. For this solid, the cross sections are perpendicular to the y-axis, are squares, right? But do not evaluate an integral expression for the volume of the solid. So we just got to set it up. So this time, the slices are going to be horizontal, perpendicular to the y-axis. They're going to be squares, right? So volume, area in terms of y, dy, they're squares. The formula for square is side squared. Here, the sides they're based off the curve. It's x right minus x left. But we need x right in terms of y and x left in terms of y. X left in terms of y is pretty easy. That's going to be y over 2. X right is going to be the positive square root of y. If you just solve this for y, take square root of both sides, plus or minus. We want the positive one because it's the one on the right. So we're integrating the y direction, 0 to 4. Don't mess that up. X right is the square root of y. X left is y over 2. dy. Don't forget the squared. This is your whole answer right here. Okay? The limits, if you mess those up, that's a point. The integran is 2 points. So that's it. And you don't have to finish it, even though you could finish it, but they're giving you a break. All right. Third one. This one you can use your graphing calculator. Okay, so we still got to show the steps. So let R be the region of the graphs y equals sine pi x, which is the sine curve, so that looks right. And then y equals x cubed minus 4x, so that's a cubic. Now the period of sine is usually 2 pi, but then you divide by this, so that makes sense. This is the period of sine, so that all makes sense. Part A, now the point breakdown here, it's going to be 3, 2, 2, 2. Part A just says find the area. So we could do vertical slices. I think that's your best bet. Y top minus y bottom. And so the area is going to be y top, which is the sine pi x curve, minus y bottom, which is the x cubed minus 4x. Now make sure you distribute that subtraction, or at least put parentheses, because you have to distribute that. We're integrating left to right, 0 to 2. Okay. And, this is fine for your setup. That can be your setup. We could go ahead and simplify it a little bit. But you have a calculator, so please don't do the work by hand here. Just use the calculator, right? You could keep doing work here, but the answer from your calculator, make sure you're in radian mode. So make sure you're in radian mode. So we're going to do math 9, and we're going to put sine of pi x minus x to the third plus 4x and comma x comma 0 comma 2. Boom. The answer is 4. If you want to make sure that you're communicating that you're trying to give 3 decimal accuracy, you might just put some zeros there. Now, alternatively, you could try and do this by hand. It would be what cosine pi x negative 1 over pi minus x to the fourth over 4 plus 4x squared over 2, 0 to 2. I wouldn't recommend doing this, but if you wanted to, you could. Cosine of 0 minus, that would be 16 over 4 is 4 plus 8. Plug 0 in, you get negative 1 over pi cosine of 0. So this was going to be 2 pi, which is 1. Cosine of 0 minus 0 plus 0. That's going to be 1. So the negative 1 over pi plus 1 over pi, they cancel each other out. You have negative 4 plus 8 is 4. Same answer. But please don't do that. Just use your calculator. Now, point-wise, that was 3 points. 1 point for the limits being correct. 1 point for the integrand. And 1 point for the answer. Okay, B says the horizontal line y equals negative 2 splits the region R into 2 parts. Write but do not evaluate an integral expression for the area of the part of R that is below the horizontal line. Below the horizontal line. So we might just draw it on here. So we're trying to find writing but do not evaluate. So we're just going to set it up for that area. Now, we could just do y top minus y bottom, right? The one thing we do need to figure out is we got to figure out the limits. So we got to figure out what these intersections are. So that's something that I think we really want to do on a calculator, because I don't think you want to set to find the intersections. You would have to set negative 2 equal to x cubed minus 4x. And even if you thought you could solve this, it's still going to be quicker to just let your calculator do it. I'd move everything to one side, equals 0. This is one of the major 4 skills I talked about in the notes that you need to be able to do on the AP test on your calculator. And so I'd put it in here, x to the third minus 4x plus 2, and then I'd go to window. I expect it to be between 0 and 2, 0 and 2, and I just want to see the x-intercept. So I'm going to leave the y min and y max negative 1 and 1. I'm going to graph it. I should get 2 right now. This shouldn't look like the graph up there because I moved everything to one side. So there's one answer and there's the other answer. So second calc, 0. This is all work I don't have to write down. Left bound, I would say, well, it's between 0 and 1. I'm going to guess 0.5. And so I just write here x equals 0.5391887. Now I'm writing more decimal places because I got to plug these in somewhere else. If you round truncated 3 decimals right now, you're going to lose points because you're going to lose accuracy. So I can calculate 0. It's between 1 and 2. I'm going to guess like 1.6. So I get 1.675139. Okay. So there we go. Now to find the area, it's going to be y top, which is just negative 2 all the time, minus y bottom, which is x cubed minus 4x. You parentheses around everything, dx. And we're going to integrate between these two values. So the area equals, we're going to go left to right, 0.539. Now for this, you could probably just write 3 decimals because we're not going to actually finish it. We could pretty easily on our calculator, but they told us not to. So if you do extra work, it could cost you points. It's obviously going to cost you time. So there you go. So that was 2 points, 1 point for your limits and 1 point for your integrand, what's inside the integral. Okay, part C says the region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. So perpendicular to the x-axis, and they're squares. So I'm going to work off of this picture, stuff I already wrote. So I'm going to draw one slice. Okay, it's a square. So the volume, they're perpendicular to the x-axis, so everything's in terms of x. It's some area formula in terms of x. It's a square. It's side squared. And the limits are 0 to 2. The side, this is one of the sides here, is y top minus y bottom. Y top is the sine curve, y bottom is the cubic. So it's going to be sine pi x minus x cubed minus 4x. And then you got to square it because that's one side of the square. So that's your setup. That's good enough for the setup. That's a point. And then use your calculator to get the answer. So I'm going to do math 9, parentheses, sine pi x, close parentheses on the sine, minus parentheses, x to the third, minus 4x, close parentheses, close the outer parentheses, squared, comma x, comma 0, comma 2. You get real quick at typing it in, and there's your answer. 9.978. 3 decimal actually rounded, truncated. That's the other point. All right. D. D says the region R models the surface of a small pond. At all points R at a distance x from the y-axis, the depth of the water is given by h equals 3 minus x. Find the volume of the water in the pond. I'm going to redraw this real quick because my drawing has a lot of stuff on it. So this is the surface of a pond, okay? And so the pond is below it. The rest of the pond is below it. It says as you go away from the y-axis, the depth is equal to 3 minus x. So when x equals 0, the depth is 3 units. When x equals 3, the depth is 0 units. So it's like gradually getting less and less deep, okay? And it says, okay, so, and I think we're just assuming the edges of the pond go straight down. So you could look at each slice as like a rectangle, okay? The depth is the height of the rectangle, okay? And then this distance is the distance between y top minus y bottom. So our volume, it's volume by cross section, but they're rectangles. So it's some area in terms of x, and they are rectangles. So it's base times height. Now the limits are going to be 0 to 2. Now the base is this distance, y top minus y bottom. So y top was sine pi x, y bottom was x cubed minus 4x Be careful with all the parentheses. Okay, so that's the base. The height is this, is the depth. 3 minus x dx. So that's your setup. We are expected to find the answer. So the setup was with point. The answer is a point. So I could have probably used some of what I wrote in the last one. So I'm going to use what I wrote in the last one. It's going to be sine pi over x. Okay. So, okay. I'm going to do delete second insert 3 minus x. I'm just, instead of retyping it all, just trying to use what I had before. It's pretty close. 8.369 truncated, or 8.370 if you want to round, but be careful. So the answer is a point. So part D was kind of weird. But again, I was telling you before, you need to average about 6 out of 9 points to get a 5 on first response. So even if you totally messed up part D, there was only 2 points. Like, you know, I think the other parts were a little more straightforward, and hopefully you get most of those points. That's it.